Hello, Scott Hebner here. Thank you for joining this episode of the Next Frontiers of AI podcast. As you know, our objective is to partner with industry pioneers to explore the latest developments shaping the future of AI, which is more important than ever as innovation cycles are clearly moving at warp speed. In today's episode, we continue our discussion about the advancements that will fuel a new generation of AI agents, capable of helping us achieve goals, make better decisions, and problem solve. To do so, it all starts with AI models that can acquire and apply knowledge. Think about it. Knowledge is gained by comprehending truths obtained through experience and the process of reasoning. Data is not knowledge. Said another way, we gain knowledge by understanding the cause and effect relationships among actions and conditions and events and consequences. And just like humans, successful businesses thrive on the knowledge they gain and apply, and their ongoing success will be determined by how well they build on that knowledge and adapt over time. Therefore, next generation AI needs to operate in a very similar way in order to drive these higher ROI use cases that so many businesses envision. If it doesn't, it will follow that businesses, want to do more than just create predictions and generate content, identify patterns, isolate anomalies, what they're doing today. What they really want to be able to do is play out countless scenarios to understand the consequences of various actions, explain what drives their businesses, make grounded decisions, and analytically problem solve at scale. In essence, they'll be able to not only understand what to do, but how to do it and why certain actions are better than others. AI that knows why things happen promises to be a game changer. To discuss this in more detail and to explain how enterprises can get started today, I'm thrilled to be joined by Stuart Frost, the CEO and founder of Geminos Software. Thanks so much for joining us today, Stuart.
Yeah, thanks, Scott. Great introduction. Excited to join you.
Thank you. Where are you right now, by the way?
I'm in sunny Laguna Beach in California.
Very nice. I'm still in Connecticut, outside New York, and it actually hit 50 degrees today, so the snow is starting to melt.
I think it's about 70 here today. Actually, it might be over that, so it's pretty nice.
Oh, good. Well, again, thanks for joining us. So, can you just tell us a little bit about your personal journey that kind of led you to launch Geminos Software?
Yeah, absolutely. It's been a long journey. So I started life as a software engineer back in England, mostly in avionics. Started my first company at 26, which was a data modeling company. Took that public on NASDAQ eventually. It was a great ride. Learned so much about building a startup from scratch and raising money and finding customers and you name it. In fact, some of the people that worked for me then, 30 odd years ago, are working for me again now, which is something I'm really proud of, quite honestly. It's an amazing kind of storyline for me personally that those people come back and say, that was the best place I ever worked. I tried to find it, even in some cases start my own business to recreate it. And I haven't been able to do that. So can I join you again? Which is fantastic. So I moved to the US towards the end of that time. Started Datalegro then, which was a data warehouse vendor. Sold that to Microsoft, so another really interesting journey. A couple of years at Microsoft under Ballmer, which was challenging, let's just say. And then I went through a period of starting a lot of companies, coming up with ideas. It was a venture studio, basically. And it were two main themes, I would say. Knowledge management, which has been a theme for a long time of mine, and early AI applications, AI models for industrial challenges. Did that for 8-9 years. A few small exits, nothing really earth-changing, let's put it that way. But what I did was I really learned a lot about the challenges for large enterprises building knowledge models, and also the challenges with using traditional AI in an industrial setting. So when I started Geminos, that was fundamentally what I decided to take on. I think it's IBM that's put a stat out there that 87% of industrial AI projects fail. Mm-hmm. That's a terrible statistic for our industry there. So what I've done is really set out to solve that and address that. So that's why we got here, what I'm doing.
Yeah. I've read some recent surveys that it's still over 50%. A majority of the AI projects that get started never make it to deployment. And some of it's for technical reasons. Sometimes it's, the talent pool. Sometimes it's the fear of it. Can it be trusted? The whole explainability issue that maybe we can get into here, because I think that's a really big deal. But how would you describe what you're seeing today in the beginning of 2025 within most of these enterprises? I think they've made a lot of progress over the last many years, certainly with generative AI and maybe some individual productivity. But I think people are starting to slow down their deployments a little bit from what I'm seeing around this issue of trust. But I'm curious what problems you're seeing as you engage probably with a lot more enterprises than I do.
Yeah, it's a daily basis, daily conversation, luckily. So I think the first challenge that we really looked to crack was correlation versus causation. And we picked up on Jadair Pearl's work out of UCLA pretty quickly. That's proven to really work out very well. And, drawing a causal model of a decision, etc., applying the math, that's going really well. We've got some great case studies now for that, some good experiences. And, so I think that's fundamental, right? Once you start going down that path of causal AI, as opposed to correlational AI, you never go back. It's just better. And when you think about it, right, what our customers want is not another AI technology. They want to make better decisions. That's their job at the end of the day. And causal AI is just a great fit for that. You alluded to it in the introduction, Okay, something's changing. It's going wrong. Why? And what do I do about it? What interventions do I make to change that situation and to fix it? So that is really resonating with customers. And I think it strikes the heart of why some of the correlational projects failed. And of course, in the midst of all this, we got Gen AI and LLMs in particular, and agents now, the next big thing. And what we've seen there is that it's kind of correlation problems writ large, right? Fundamental issue with LLMs is they are just big correlational engines. They don't understand the cause and effect. And what we started to do is take the first steps to addressing that. And, we'll maybe show a couple of slides in a little bit, but, I think that is core to it. People are still struggling with it. I mean, I don't know about you, I've got Apple Intelligence on my phone.
Mm-hmm.
It's not intelligent. I would say 40-50% of the time it gets the meaning completely wrong when it's summarizing an email thread or something from Teams or something. I mean, I had a big customer trip overseas a few weeks ago. And just before I was leaving, Apple Intelligence gave me a notification that the trip had basically been canceled. It had just completely misunderstood the emails. So you can imagine I'm like about to get on a plane and there it is, So clearly that's not going to work for business decisions of any importance, right? So we've got to fix that. And agents suffer from the same problems because they're driven by LLMs right now. So once you go through a few steps, right, you've only got to get it 78% of the time right. And before you know it, you're getting it wrong most of the time, right? If you go through a few steps of an agent, so it compounds. So that's something that we're really starting to tackle with these Causal Knowledge Graphs, which is the next kind of big release that we're going through right now.
Yeah, no, you're 100% right. I mean, I've been talking to dozens and dozens and dozens of companies, particularly around agents and agentic systems. And I still think there's a lot of, I don't want to use the word confusion, but maybe different opinions on what an agent is. But I'm of the mind that it has to be different than an AI assistant that we were all used to with generative AI and all that. And what most people would say is that the agents, can help you achieve a goal and help you make decisions and problem solve and even act autonomously if human intervention is not feasible or affordable. And you cannot do that based off of an LLM in today's state because it's all just correlation, right?
Right.
It doesn't understand consequences and a whole bunch of other things. And that's why we've been driving this notion that you have to build models around the LLMs, right? An ecosystem of models that are going to give you exactly what you're saying. Because an LLM, I mean, first of all, as you were saying, correlation does not necessarily imply causation, and a prediction is not a judgment. You need judgments to make decisions, and you kind of just go down the chain, and you very quickly get to the conclusion that these aren't built to help people make decisions. And actually, if we bring up that chart on making better decisions, maybe you can talk just a little bit about, what you're seeing, Causeway being able to help your product help businesses eventually do here as they deploy this stuff.
Yeah. So it does come back to this. Okay, I'm an operator. Let's say I'm in a refinery or something, right? And I'm managing some process. Maybe it's making PVC or something ultimately. And I want to minimize downtime or something, right? Well, okay, great. So maybe I see from some algorithm that my downtime is starting to deteriorate. That's classic AI. It might tell me it's getting worse, but it doesn't tell me why or what to do about it. So with causal AI, we can change that, right? The Pearl's math drives directly at that because we can build a causal model, which is a simple chain of if this variable changes, this one is going to change as well. And maybe it's in phase and maybe it's out of phase and how much it's going to change. And so immediately we've addressed a lot of the explainability and transparency problems because we've actually built a model, right? We've understood and broken down the problem into a series of steps. What we can then do is deploy that model. So we build it based on historic data, understand what we can do there. We play around with it and test counterfactuals, interventions, etc. Get comfortable with the model, make sure we don't have any critical unobserved variables, etc. All those kind of things, which is none of that we do with traditional AI, right? We apply a big algorithm and kind of hope it's working. Being a little unfair, but it is what it is. But then we can actually deploy it alongside the running business system. So we can take the latest slice of data and say, how is this different to what we were seeing historically? And if the mean is changing, the variance is changing, we're seeing outliers. Why is that? Because we can kind of play back through the causal model and really understand the root cause of it. And then what we can do is play around and say, well, what if I changed the pressure or the temperature or the flow? What would happen? Would it fix that problem? And Pearl's math just works for that kind of stuff, right? It's such a big breakthrough. And as I said earlier, once you've gone down this path and you've seen the power of it, you don't go back. Right? As a data scientist, it's just better fundamentally. A bit of a barrier to entry in terms of really deeply understanding it, but it's not so high. And what we've done is really built the tool set around making that a lot easier. So yeah, it's quite honestly, as you probably tell, I'm pretty enthusiastic about this, pretty nerdy about it. But I love going into customer situations where they've struggled, they've tried different things, they've tried various forms of AI, and we can go in and within weeks just show them a better way of doing it and get them better results. And it very quickly spreads across the organization then. So that's a pretty cool cycle as a startup guy, right? You don't get too many opportunities to do that with big organizations and big decisions. You don't usually get access to that kind of stuff. So it's very cool.
Yeah. As a guy that's been in the middle of product management and marketing my entire career and been across all different kinds of businesses in high tech, I don't think I've ever seen a more necessary and inevitable market that's going to develop than this. I mean, AI agents and agentic AI, if anything, is going to drive the need for this because, if you want these things to act autonomously or help you make a decision, it's just not possible, even with more advanced RAG and even with knowledge graphs. And we'll get into the causal knowledge graphs here in a second. But I really like your concept of the slow and fast decision making. And maybe just explain that for a second, because I think that kind of captures the essence of what you're talking about here.
Yeah. So This is kind of a parallel with Daniel Kahneman's Thinking Fast and Slow, right? I think everyone's pretty familiar with that, the book and the concept and the Nobel Prize and so on. And what occurred to us is that if we can drive LLMs in the right way and give them a good knowledge base, they can be really good at answering those kind of fast decisions, right? That you don't need to be too accurate necessarily. You want some information pretty quickly. You want it to be pretty accurate, right? But you're not going to drive your PVC manufacturing process with it. That's too dangerous for one thing, right? But in terms of getting information out across the organization, and this is really important, I think, capturing that knowledge and then sharing it is a really powerful concept. And what we realized is we could use the LLMs to build a knowledge graph that then, using a form of RAG, we call it CRAG, Causal RAG, we can actually give it a much better foundation of understanding and get much more accuracy from it. We've got some neat little videos on this that people can point to on the website, etc. So it's great for that kind of thing, right? And that's been one of the big challenges in large enterprises. We talk to a lot of people in oil and gas, for example, where employees have been around for 25, 30 years. A lot of that knowledge is not only leaving at the end of the day, it's leaving at the end of their careers and never coming back. So there's an urgency to capture that kind of knowledge. A couple of problems with that in the past. One is it's never really static, right? It's constantly changing, ontologies, etc. All that so hard to deal with. They were never finished. LLMs give us an interesting opportunity there because for the first time we can kind of ingest a lot of knowledge from documentation. We can start to use agents to go and get clarification from subject matter experts to capture that in the knowledge graph as well. So what we're finding is for the first time in decades of trying to build these knowledge graphs, we can do them in a meaningful way at scale and at a useful pace to actually solve a lot of these challenges. And then we can share that knowledge using the LLM. So that's becoming really powerful, and we're getting a lot of interest in that. We've got a couple of big rollouts kind of pending at the moment of that technology. But those customers also need the more kind of slow, specific decisions. Got to be very data-driven. I've got to be precise. Because those key decisions are often, for one thing, they're driven by actual structured data, like sensor readings, etc. LLMs can't do that. So we need Perl's math behind that. Well, that's great because now we can also use all that knowledge that we're gathering about the organization to help us build causal models more quickly and more accurately as well. So it's kind of a really interesting virtuous cycle going on here, in that we use the LLMs to build the knowledge graph. We use the knowledge graph then to drive more causal models at scale. That helps us make better decisions, and we can feed that causal experience and the actual practice of working on data and making decisions back into the causal knowledge graph. So once that gets rolling, it becomes really powerful. So for me, as a kind of a AI knowledge graph guy for quite a long time now, I really feel that we can deliver on the promise of all that for the first time, right?
Ironically, it's almost like I planned this, but I didn't. Last week, the podcast I did last week was with Jayada Pudatanda, who's the director of the AI Center of Excellence at Fitch Group, Fitch Ratings on Wall Street for the bonds and all that. And she basically made the case for the need for things like causal RAG, right? But we didn't get into how to do it. And I think what you're going to do now is you're going to start, let's make that transition to what you guys are enabling in your products, namely the causal knowledge graph. And then maybe as you do that, you can tie back to how the causal RAG fits into that. And that would tie the here.
Absolutely, yeah. So let's talk a little bit about RAG and graph RAG first, right? Because that's the kind of foundation of it. So RAG was the first attempt to give LLMs a better foundation. The problem is It's based on vector databases, which is just a similarity engine. And a lot of the times it just gets it wrong. Things that were similar in one domain are just not similar in another, right? Like Apple is a computer brand and also a fruit. Well, there's some differences in the similarities there. So GraphRag was then developed by people like Neo4j and Microsoft as a means of actually putting an actual graph database behind it. And that really kind of resonated with me, right? I'm a database guy, I'm a graph database guy. So that really fit my kind of psyche, if you like. What we realized is that those traditional knowledge graphs, entities and relationships and so on, what you might call kind of the static information of a business, static knowledge. Yeah, I understand how many sites I've got and what's in those sites, different pieces of equipment, and might understand who works on those. But it's always been missing the dynamics of the business. And what we've realized is that causality and causal models give you that dynamic information, right? This is changing. This is going to change. How much? So adding in that layer of causal knowledge really kind of starts to complete that picture of knowledge, right? It's telling you, yeah, I don't just have things and relationships between things. I've now got causal stuff going on. So I understand if something is changing, what effect it's going to have. And that really, to me, is where there's so much more value in the knowledge. Now, you can decide how far we get into this conversation. In some ways, what we're doing is a kind of neurosymbolic AI, right? We're starting to combine the Gen AI, the neural networks, etc., with symbolic AI, which used to be rules-based AI. What we're saying now is actually, it's kind of, because we understand the variables and the interactions between them, we don't necessarily have to have a rigid rule structure there. We can use the causal math to understand what's going on and be much more dynamic and much more powerful and much more flexible about how we build a kind of combination hybrid system of neural networks and symbolic systems. And I think that's a really interesting future research path. And we're also looking at how we can use LLMs to capture business rules, not just cause and effect, but, something's under warranty and someone comes back and it's within the first year, you replace it. Okay, if it's outside the first year, you recommend a repair, those kind of things, right? They're in the documents, and the LLM can make a pretty good job of building a rule system. We'll build that into the knowledge graph too. So that's kind of the next phase of where we're going with this, to really start to build that neurosymbolic foundation, which is a very exciting path from, as I say, decades of trying to get this stuff to work at scale. I can finally see a path to do it all.
Yeah, I mean, that's one of the points I've been making as I talk to people about the correlative model, design. The LLMs is they're only as good as you expect your future to be, just like the past, which isn't really true in any business, because you're always trying to improve things and conditions around you change. And you're referencing Judea Pearl a lot. I mean, what a great book. One of my favorite quotes in there, which I think supports what you just said, is, what does he say? That probabilities encode our beliefs in a static world. Causality tells you how those probabilities change when the world around you changes, right? And you're right, it's the math that you're not just correlating things, you're understanding like real cause and effect which is the foundation of how all humans operate. Right? Exactly. The alarm clock goes off, and do I hit snooze or not? You're thinking cause and effect.
Yeah, exactly right. It's how we interact with the world, and therefore it's kind of got to be a part of AGI at some point. Yeah, not going to happen without it, right? And the idea that it's just going to emerge from an LLM, I think that's largely debunked now with most people. But it was always kind of dumb. Sorry, but it was never going to happen, right? And the other issue with LLMs is it's not just that they can only predict the future based on the past, but sometimes they just wander off into hallucinations and get it completely wrong. Now, Now, I was researching ontologies for oil and gas, and I asked, I can't remember which, I think it was Llama, and it completely invented this whole body, standards body in Houston, headquartered there. They got this monthly journal. I couldn't find it anywhere. So I went back and said, IARP, I think it was. What is that? Can you give me more information? Oh, sorry, I made that up. Completely made up from whole cloth.
It's
So
just,
that kind of, just wild hallucination stuff, you can't use them raw like that in business, right? That's just not going to work.
when you have what is it,
deal.
hundreds of billions of parameters and trillions of tokens, and these massive, unbelievably complex machines are just predicting the next, best token until something about that seems like it can't be 100% accurate. But I think the concept of very simple concept that correlation doesn't imply causation is the most important concept for people to start to understand. Because I use Gen AI all the time, right? And I think a lot of people, businesses, it's great for individual productivity, but that's not where the real impact is going to be. And I think it's what you guys are building, that they're starting to democratize all these concepts that you've been talking about so far. And if Brendan, if we can bring up the chart on the causal knowledge graph on just how you see that fitting within sort of an enterprise setting. There you go.
Yeah, obviously a very simple view of it, but to go back, I think, to what you were alluding to earlier, Scott, agents and so on are not going to work very well. LLMs, whatever these technologies are, they're not going to work very well if they don't know what our business is about and what the constraints are and what the cause-effect chains are. How are they going to do that? They can't just pick it up from one small bit of context. They've got to understand how our business operates in order to help us. So to my mind, the causal knowledge graph is this opportunity to provide a foundation for all of the AI technologies a business wants to use, not just causal AI, but LLMs, agentic AI. They all need this information in a standardized, structured way. And we need to be able to build that in a way that's, plugs into our data lake, plugs into all our unstructured data and structured data. And that's what I think LLMs are really good for in this, as I said a couple of times, right? Extracting knowledge from all that information, they're really good at. Now, it needs curating. We need to resolve for hallucinations and so on. But it's worth putting that investment in if it's truly going to give us this foundation for all our AI initiatives going forwards, right? So we can't today just completely automate building a causal knowledge graph at enterprise scale, but we can go a long way towards doing that. And we can use agents, as I said, to interview subject matter experts. We can correct things where there might be some confusion in the graph. We can go back and ask them, the subject matter expert, did we do it right? That's a really simple use of an agent. That can work quite well. And over time, then we can curate this knowledge graph in a way that we could never just never do before, quite honestly, in any kind of effective way. But providing that foundation for everything going forwards, then it just accelerates the value right across the board, right? And we can do it at a true enterprise scale, which is also really exciting. We're not just doing this on little pilot projects and toy examples. We're doing this for oil and gas companies and manufacturers and so on, at industrial scale. Haven't yet quite figured out how to do it at true kind of global scale, AGI scale, but within a given domain where it's worth investing in the curation, etc., and getting that knowledge graph accurate. It's incredibly powerful and it's working. It's a beautiful thing of it.
As my old boss used to say, no miracles required, just progress, right? Just keep incrementally making it more and more, capable, reason better. Then you can start to, it's a journey that everyone is on here. And what AI can do 2 years from now is very different than today, just like it was 2 years before. And these innovation cycles, I was saying up front, seem to be going even faster and faster every year that goes by. And that actually, what is your take on, OpenAI came out with Chain of Thought, and then DeepSeek, and then IBM announced it with its Granite models yesterday. I'm curious to what your thought on that is, because it's positioned as AI reasoning, and I've sort of come up with the thought that it's like the first rung in the ladder.
Yeah.
But eventually you got to get to semantic reasoning and causal reasoning, and then they maybe want some kind of swarm where you have multiple models or agents working together. What do you think of the chain of thought? Do you consider that to be reasoning?
Not really. It's an aspect of it, right? As you said, it's on the bottom rung of it. But reasoning in the absence of all that fundamental knowledge isn't going to get you there, right? It's like, so I still think that that knowledge base, especially in a corporate environment, right? So it's not there in the original training of the LLM. It's incredibly expensive to train an LLM on all that properly. So it's just not going to get us there in isolation. So the way I look at it is, it's wonderful that all this LLM technology is getting better and chain of thought and everything else. Great. That over time makes our usage of them as tools even better, right? Makes our life easier. But it doesn't change the fundamental challenge that they lack the knowledge they need to help our customers make better decisions. And I don't see that changing, right? You can't algorithm your way to doing that. You've got to put the grunt work in and create the knowledge graph, embed that in everything you're doing, and then use those tools and benefit from the virtuous circle of the feedback then, right? And then everything gets better quite quickly. And we're starting to see that in some of the early deployments that we're doing. It does start to accelerate. So I personally feel like we're onto something really powerful here. It's kind of a missing piece. There aren't too many other people in the world thinking about this and doing anything in real practice, right? Solving problems for customers with it. I think we're about the only one, really. So, it's really exciting from that perspective as well. Because I still think all that kind of Gen AI stuff, it's just throwing more and more computing at the same problem, right? Yes, some algorithmic improvements here and there, DeepSeek, etc. Not changing it fundamentally, right? Not fixing it.
In my predictions for the year, I mean, I equated LLMs and generative AI to the browsers of the early internet age, where that was the biggest decision in the world of what browser you picked. But it ultimately became part of the foundation, and it essentially was a gateway into the internet. I think Gen AI is going to be sort of like part of the infrastructure soon. It's going to be not that differentiated. You're going to pick one and go with it, and it's a gateway into AI. But where businesses are going to get the value is building the ecosystem around it.
Yeah.
And my view of chain of thought is it's a great advancement, but it's still based on a correlative design, right? And
Absolutely.
yeah, it goes back and thinks, and it breaks down. I mean, it's a big advancement, but it's a baby step in the journey to getting what I think where you are now, are very, very damn close to it, is getting the infrastructure in place where you can actually build, like mere mortal. You don't have to be like a PhD data scientist to build this stuff now, right?
Well, and I think it also importantly, you don't have to throw $100 billion at it. Right? Which is also quite nice from a startup's point of view. I mean, this whole push to just spend hundreds of billions, $500 billion, it's going to be looked back on, I think, as just an enormous waste of money, right? I was responding to a tweet thread. Was that an X thread? I don't know. This morning about someone was saying, "Oh, Apple is so far behind. They've got $250 billion sitting on not doing anything with LLMs. So far behind in AI." I'm like, despite my comments about Apple Intelligence, I actually think they've figured it out. Like you, right? They're like, LLM stuff, cool, useful tool, is it worth us spending $200 billion just to be another player with another commoditized LLM? Really? No. And you're seeing this with Satya at Microsoft, right? Maybe we're not going to build so many data centers out now. Yeah, maybe we're thinking about this in a slightly different way. So I think the light's starting to go on with a few more people, and it's going to be really interesting to see how that plays out.
Yeah, I know you guys are making one of the points about, which not everyone else is doing, about with the causal knowledge graph and just causal AI in general, you can understand and rank what the influence is of all the variables in the system and perhaps eliminate a lot of them. And you end up with smaller data sets that you need to manage, and therefore they're going to be higher quality. And you're not going to need these massive GPU farms where Gen AI is brute force, right? That's why there's trillions and billions associated with all this stuff. Not every business can afford that, right? So,
well, especially when all you end up with is another commoditized LLM, right? Basically, I mean, it's very hard for anyone to get ahead of that game, and to what end, So, yeah, it's been fascinating, right? As a startup guy, having done this for a long time, to kind of find myself in the midst of this very rapid innovation cycle where some players are just spending crazy amounts of money, right? Literally hundreds of billions of dollars, and we're here doing largely funded by customer revenue, solving real problems. It's such an interesting contrast, and in 30 odd years of doing startups, so I've never seen it so extreme.
I think it's going to change, because that's what I meant by the inevitable comment before. Is my observation with over a year of talking, talking to people about this, is as you really think through it, it just makes a ton of sense. I mean, yeah, I want I want things to be not just correlation. I want to make sure they're valid, because it's confused with causation. They want judgments, not just predictions. And you start talking through this all, and it's like, yeah, that's really what I want. I want to be able to make decisions, and I want to be able to trust them. The only way I'm going to trust them is if it can explain to me why this decision was better than alternate decisions I could have taken. And and that's what people are just going to want that. And then you very quickly get to what you're talking about, right?
Exactly.
So before we wrap here, I'm gonna Brendan, could you bring up the scary chart, what I call the scary chart? That's it. It's not that scary, but I think this goes to what I know this isn't swarm intelligence necessarily, but this idea that things learn from each other, and it's almost like a microservices approach for causal. Like, just could you explain this? 'Cause I think this helps to bring home the fact that your enterprise wide or enterprise scale, right?
Yeah, no, thanks for bringing that in. So what we have is, in this context, I'm talking about a knowledge model more in its traditional sense of my entities and my variables, right, and how they're related and so on, which might be fed from that knowledge graph, the causal knowledge graph the LLMs helped us build. But what we're highlighting here is that a decision has a causal model, right, with a specific outcome, certain interventions I can make, maybe some reusable fragments we call them component causal models, that we can reuse across the enterprise there. And as we make decisions and make interventions, we're changing values in the underlying kind of fabric of the organization, which impact other decisions. So, in a simple example, right, if I decide that in order to extend the life of a particular component in a PVC manufacturing process, I mean, one part of it part of it's going to go down sooner than I'd like. Okay, maybe I want to reduce the flow through that component. Well, that means the next stage in my PVC manufacturing process is going to get less flow. What does that do to that set of decisions? How might I counter that? And of course, overarching it is, what if I need to make a customer delivery? I need a certain level of output for that. And what does that do to my profitability if I miss that? So in a real world organization, all these decisions are interconnected. And really, for the first time, we have a scientific basis and a mathematically underpinned basis for dealing with all that complexity. So that when an individual operator is making a decision, they're getting wired into all the implications of that decision. Not just doing in isolation based on whatever they learned 10 years ago when they were trained on that piece of equipment. So for the first time, an organization can go, wait a minute, I'm actually going to have to put some constraints on what you can do, right? Because my profitability is going to get impacted 10 months down the line if you make that decision. And those constraints can be kind of built into the system as well. So means actually you can only change that variable by 5% today. Sorry, you can't do it by 10%. Okay, well, what else might I need to do? Well, maybe I need to increase the temperature at the same time as reducing the flow, or whatever it is, right? So that's what we're trying to get across in this graphic, that these decisions are connected. It's great from our point of view because if the customer buys into it to make one decision, some critical thing that we're finding actually some of these have an ROI in the tens of millions of dollars, which is kind of neat as well, because these are the big, challenging decisions, right? When stuff breaks, it's millions in downtime. So we get in through those kind of decisions typically in the door, and then they very quickly go, actually, there's a ripple effect here, isn't there? Oh, we need this for other decisions as well. They're connected. So it has a kind of viral nature in the organization, which is kind of really cool from a startup's point of view again,
Yeah, that's what I find really, I mean, this is where it really starts to hit home with me, because you're right, decisions are interconnected. There's one thing about an individual, helping an individual make better decisions, but when you're looking at an organizational flow where teams of people, need to work together to serve a customer or to manufacture something, it's all interrelated. And that's why I like this idea that, sort of the tagline, right, which is AI that knows why, but at the system level, it knows not how you think your process works, but how it actually works. And when things start changing, it can tell you. And I think that just nails AI that knows why, kind of nails that value proposition. So
yeah, it's kind of interesting, because we came up with that very early. One of my colleagues actually came up with it, an old friend of mine. And it really does encapsulate it, right? And for people who are trying to use AI to make better decisions, it just resonates with them. They kind of get it. They're intrigued by that tagline, which is what you want from a tagline, right? And then you can give them more detail. So I'm really happy that you've highlighted that and agree with us on that. We love it. And it really is a differentiator, right? Because most of the time with AI, you don't know why.
Right. Today AI will tell you the what, right? But not
Right,
how.
exactly.
That in the why. Well, look, Stuart, thank you so much for taking time to be here. I wish we can go on for, I can talk about this forever, but before we go, people can contact us. We'll bring up our, through LinkedIn. But what would be your key call to action here? I mean, obviously, people should go to Geminos.ai, the website. Did you want to throw a call to action out there for people?
Yeah, I think if you're really struggling with this problem of how do I make better decisions? How do I use AI to help me do that? Please reach out to us. We'd love to hear from you. We'd love to tell the story of how we're doing it. It's not always going to lead to a customer situation, but we both learned from that. Obviously, we'd love it if there's revenue too, but we're right at the kind of forefront of solving these big problems. And the more conversations we have about it, the more we'll learn collectively about it. And I think spread this word that Causal AI is just a great way to do it. That's just better for the whole community. And I think at its core here, there's something really important in this, as we've talked about a few times here, Scott, and getting that across to people, getting them to realize why this is important, why it's such a big breakthrough is my kind of mission, if you like. So feel free to reach out to me and have that conversation. I'd love to do it.
Yeah. And you talk about differentiating over time. This is what's going to make a huge difference here for anyone looking to use AI to differentiate their business. All right. Well, super. Thanks so much again for joining us today. It's been a very inspiring conversation, to say the least, and keep us up to date on progress. And for all you, Thank you, as always, for joining us here on the Next Frontiers of AI podcast. I so appreciate you tuning in. Stay tuned for more research and analysis from our team as we keep diving deeper and deeper into what's shaping the future of AI. And also mark your calendars for April 16th, as we will be hosting an industry unique summit featuring industry pioneers discussing how to best climb the ladder to agentic AI, which of course includes AI knowledge and reasoning, right, so these things can make decisions. But in any event, we'll have some more information out on thecuberesearch.com and siliconangle.com. So stay connected there, and look forward to that announcement coming up sometime in mid-March. So thank you again for joining. We'll see you next round. We are the leader in tech news and analysis. Bye for now.